Okay, in the previous video we talked about how to identify lines that were parallel. We found the slopes of the lines and compared them. If the slopes of the lines were the same, then we know that the lines had to be parallel. In this video we want to go on not just to work with lines that are parallel, but also to work with lines that are perpendicular. What do we mean by perpendicular? We mean perpendicular means that lines cross at right angles or at 90-degree angles. And I have a note over here that says perpendicular lines have slopes that have opposite signs and are reciprocals of each other. So very quickly, let's see what that looks like. So if I want an original line has a slope of -4, then a line that's perpendicular to that line has to have the opposite sign. So it's going to be positive, and then it's going to be the reciprocal, and the reciprocal of 4 is 1/4. So original line has a slope of -4. A line perpendicular to that line will have a slope of 1/4. Let's try one that has a fraction as a slope. If you have an original slope of 1/3, a line perpendicular to that line will have a slope of -3. If you have an original line that has a slope of -3/5, then the new slope, or a slope perpendicular, the slope of a line that is perpendicular to that line will have a slope of +5/3. So I hope that makes sense, and let's go on and take a look. So as we did with parallel lines, if we want to compare two lines to see if they're parallel or perpendicular, or neither, we first need to identify their slopes. Fortunately, with the first line, the slope is clear here. It is simply 4. With line B, we have x plus 4y is equal to 3. And what we need to do is solve for y. Put the equation into slope-intercept form. So we do that by subtracting x. We end up with 4y is equal to -x plus 3. Divide by 4, divide by 4, divide by 4, and we end up with y is equal to -1/4 x. Remember that -x over 4 is the same as -1/4 times x plus 3/4, and what we're really interested in is what is the slope of that line, and it happens to be -1/4. Now we can easily see that lines A and B have opposite signs and they are reciprocals of each other, so therefore A and B are perpendicular. Next, we'll go on to line C. Line C, we have -8y minus 2x is equal to 16. What we want to do here is to isolate the y. We do that by adding 2x to both sides. We end up with -8y is equal to 2x plus 16. Dividing everything by 8, I get y is equal to 2 over -8 is the same as -1/4. Then the x, 16 divided by -8 is -2, leaving us with a slope of -1/4. Now we can see that lines B and C are parallel. And lines A and C are perpendicular. All right, so that's what we're trying to do here. We want to compare the slopes of different lines. If the slopes are the same, the lines are parallel. If the slopes are opposite signs and reciprocals of one another, we know that those lines are perpendicular. So in order to accomplish this, we first need to write the equations in slope-intercept form, identify the slopes, and then compare them. Okay, we'll go on to example 4. With example 4, we want to write the equation of a new line. So first of all, it's important that you realize we're trying to find the equation of a new line. We're given an old line, and this new line needs to pass through the point -3, 1, but it also has to be perpendicular to the line y equals 1/2 x plus 3. So first of all, I would say that the slope of the old line is 1/2. But we want to be perpendicular to that line, so that means that the slope of the new line would have to be opposite signs and reciprocal. So if the original one was positive, the new one will have to be negative. And if the original one was 1/2, the new one would be the reciprocal of that, or 2. Now, so we want a line that has a slope of -2. And also we want that line to pass through this point, -3, 1. What do we use to construct our new equation? We're going to use the point slope form. So y minus y1 is equal to m times x minus x1, plugging in our point and our new slope. So the y coordinate is 1, so we get y minus 1. The slope is -2. X minus -3 would be x plus 3. And now we're simply going to multiply everything out. We get -2x minus 6, y minus 1. Add 1 to both sides. Y is equal to -2x minus 5. And that's all we want to do here. We want the equation of a new line that passes through the point -3, 1, and it's perpendicular to the line 1/2 x plus 3. Now, we can tell just by looking at our slope that the new slope is an opposite sign and reciprocal of the original slope. So we know that our line is going to be perpendicular to the original line. Then how do we know for sure that it also passes through the point -3, 1? Well, we can ask the equation, when your x value is -3, what is your y value? And so we plug in x is -3, -2 times -3 is +6, minus 5, and the equation says back, when my x-coordinate is -3, my y-coordinate is +1, and so this line is perpendicular to 1/2 x plus 3, and it also passes through the point -3, 1. So my answer here is y is equal to -2x minus 5. What I want is the equation of a line. Now, what I'm going to do now is to go through the monitoring progress problems with this section. And we're doing things fairly similar to what we did in the previous examples. So what I want to do is to find the slopes of each of these lines and then to tell whether or not the lines are parallel or perpendicular. Again, I can only tell if they're parallel or perpendicular by comparing their slopes. So the first line, 2x plus 6y, is -3. I want to isolate the y, so I subtract 2x on both sides, and I get 6y is -2x minus 3. Divide everything by 6, and I end up with y is equal to -1/3. -2 over 6 is equivalent to -1/3, and -3 over 6 is equivalent to -1/2. What's important here? What is the slope of that line? And it is -1/3. Next, I go on to the second line. And fortunately, it's already in slope-intercept form, so all I have to do there is identify its slope. It has a slope of 3, and right away I can see that lines A and B are perpendicular. Now, will lines always be either parallel or perpendicular? No, not necessarily so. But in this case, if the slopes, or whenever the slopes, are opposite signs and reciprocals of one another, then they will always be perpendicular. Whenever the slopes are the same, then the lines will always be parallel to one another. Next, with the next line we have negative 6y plus 18x is equal to 9. If I divide, don't divide. We don't divide until we isolate the y term by itself. So I'm going to subtract 18x from both sides, and I end up with negative 6y is equal to negative 18x plus 9. Now I divide everything by negative 6, and I end up with y is equal to negative 18 divided by negative 6 is positive 3, then x, and positive 9 divided by negative 6 is negative 3 halves. What's important here is, what is the slope of this line? The slope of the line is 3. So what I have then is, I can tell that lines B and C are parallel, because they have the same slope. And also, I can now see that lines A and C are perpendicular because their slopes are opposite signs and reciprocals of one another. All right, I'm going to go on to number 4. With problem number 4, I want to write an equation of a new line that passes through this point negative 3 comma 5. I'll label that x1, y1, and it's going to be perpendicular to the line y is equal to negative 3x minus 1. So remember that the slope of the old line, we can tell just by looking, is m is equal to negative 3, or the slope is negative 3. The slope of my new line then would have to be an opposite sign. So if the original was negative, this one will be positive. And it has to be reciprocal. So if the original were 3, this will have to be 1/3. Now that I know that, I can put my equation into point slope form, or put my data into point slope form and solve for y. So y minus 5 is equal to 1/3 x plus 3, since my x-coordinate is negative 3, and now I multiply out 1/3 x plus 1, y minus 5. I add 5 to both sides, and I end up with y is equal to 1/3 x plus 6. And that's all that I'm looking for here, is the equation of a new line that is perpendicular to the line y equals negative 3x minus 1 and passes through the point negative 3 comma 5. Well, I know that this line is going to be perpendicular to y equals negative 3x minus 1 because its slope is 1/3 and the slope of the original line was negative 3. They are opposite signs and reciprocals of each other. Now, how would I know that this passes through the point negative 3 comma 5? Well, I ask the new equation, when your x-coordinate is negative 3, what is your y-coordinate? And it says to me 1/3 times negative 3 is negative 1 plus 6 gives me 5. And it says that when my x-coordinate is negative 3, my y-coordinate is positive 5, which is the point we want to pass through. And so now I know that my new line, y equals 1/3 x plus 6, is both perpendicular to the original line and passes through the point negative 3 comma 5. So that'll do it for